In this video, we are going to implement universal shift register on FPGA board. Now, as we are aware that universal shift register is capable of serial shifting your data from left side as well as from right side. Along with that, it has a functionality for parallel in operation as well. So this shift register can perform 4 different tasks where you can shift your data as per the truth table for shift register. Clear signal S1 and S0, these are two select lines which will simply select the mode of operation for your universal shift register, clock signal and output. As this is 4-bit shift register, that's why output that you will generate it, that is of size 4-bit. So consider this condition if your clear signal is 0, irrespective of S1 and S2 are don't care, and even clock is don't care. In that case, the output for universal shift register will be 0. If clear signal is given as a high signal and S1 as well as S0 is 0 0 and clock is applied at the positive going edge of the clock, then the output you will appear at the universal shift register will be no change. Now for this universal shift register, start writing your VHDL code. For that you will write VHDL code using Xilinx. So go to the file, create new projects for your universal shift register. After that, select the family selection Spartan-3E, device XE3S250E, PQ208 is the package and speed is 5. Click on next. I will add source once the project file will get created. So now finish. After that, you have to add your source to your project. So go to the file, go to the project, add a new source, and once you are there in this window, you have to add VHDL module. You have to give the file name. Finish. Now this VHD file will be created with the entity and architecture. As entity, you haven't added your sources yet to this particular VHDL code. So now, very first thing you need to add is your entity. Now, as per the entity, here are my port declaration. In that manner, I will write port data. Signal is data in. Again, it is input direction signal. So you will write standard logic vector of size 4-bit. So that's why you will write a 3 down to 0. Then there is a selection of your SEL signal. Now this SEL signal is two-bit signal. So you will write 1 down to 0. Then you need to select the shift left in data, shift right. Again, this will be your in data. There is a data out as well. This is again 4-bit signal. So you will write data out as an out signal with standard logic vector. Okay. Here you have to give data. Signal is data in. Again it is input direction signal. So you will write standard logic vector of size 4-bit. So that's why you will write a 3 down to 0. Then there is a selection of your SEL signal. Now this SEL signal is two-bit signal. So you will write 1 down to 0. Then you need to select the shift left in data, shift right. Again this will be your in data. There is a data out as well. This is again 4-bit signal. So you will write data out as an out signal with standard logic vector. Okay. So in architecture, again, temp variable is declared. So this temp variable is nothing but whenever reset pin is initiated, you need to assign the value as a 00 when reset is 1. So for that purpose, you require this temp variable. So in order to do that, you will assign if your reset is high, then temp is allowed at temp will assign with the data as a 00. Else, else it need to monitor clock. So there we need to define clock tick event, and clock, as we are mentioning, is positive going edge of the clock. So we need to assign this with the 1. Otherwise, for the negative going edge of the clock, this 1 would have been replaced with the 0. So in order to that, as clock is being applied, so in order to that, you need to select the check the status of your select line. So based upon that only, you need to monitor and modify the shift register as per the working operation of your select line. So here I will mention case statement. So what is the status based upon the select line? So in that manner, you will say that if case is, then there are possible 4 conditions. So in that manner, you can say that when select line status is, let's say 1 1, then in order to that, it should be monitored with the temp variable. Now, what is the condition for that particular temp variable? That will be assigned as a same data in, because this is parallel mode of operation. So whatever input will be there, that will be appeared at the output. So your temp variable will be loaded with the data in. Another case will be there when your select line status is 0 1. So if it is 0 1, then your temp variable must be loaded with the shift left operation. So for that matter, you will write temp variable that will again get shifted 2 down to 0. and which one more bit is added into it for to make it as a 4-bit signal. So of course you are talking it about for 01, it is left operation, so you will take a SL underscore in. So all the time your shift left input will get masked with the variable whatever the data will appear at the temp, and as per that you will able to have the shift left operation with this respect. For the another condition, for the shift left, again there is a shift right. So for that purpose, your select line signals are 1, 0, and the assigned data will be opposite of your previous condition, which is nothing but temp variable has to get loaded your temp data, and that is reversely shifted. After check syntax, now you have to click on View RTL Schematic in Synthesize and XXT. If you double click on that, the RTL schematic for your shift register will get generated. So this is RTL schematic for your universal shift register. Now to check and synthesize this universal shift register, we have to create Testbench waveform. For that purpose, we will go to the project and we will create new source. In this particular new source, we have to click on Testbench waveform, and here we have to give this file name. While selecting this, they will initialize your clock source. So clock information is single clock, and the initial length of test bench is 1000 nanoseconds. So this time scale we have to select and go to the finish. Now here we have to give the input. So here is I'm selecting DSR as a 1. DSL is right now 0. Clear is activated. Clock is given. Data in. So here I'm giving the randomly data as 1, 1, 0, 1, 0. After the simulated result, now we have to generate the same universal shift register. To do that, we have to change this source from behavioral simulation to synthesis and implementation. So change this source. Under this particular processes, you will able to see this user constraint. Click on that user constraint and assign pin package. So the pin package you will select as per the pins that are allocated to your shift register. Based upon that, you can able to change the input and output condition for clock reset, data in the fact of serial left shift or shift right. In that manner, with the respect of your select line status, output will get appear. So as P208 package, PQ208 is the package. So FPGA pins assigned for the respected clock reset, data out, data in, serial left, serial right for the selection lines. So these are the pin numbers. So we have to assign this column as a pin number for this particular signal name under the pin package. So in order to that, your clock is assigned with 555 timer. Near around 1 hertz clock is applied, and for that internal pin is allocated as P. As per the pin package, you have assigned all the pins. under the user constraint assignment of pin package. Now it's time to generate the programming file as per the your pin numbers which you have added as per the your FPGA kit. After creating bit file, go to that respected project folder. Here in this case is universal underscore SR was the folder. So inside this folder, once a pin assignment is done, you have generated that program file, due to which .bit file is created under this particular folder. So here is my bit file. You need to copy this bit file into FPGA download folder, and you have to paste that file in this folder. After that, you have to edit this FPGA download file. Under this file, the JTAG executable program will be there. So through that JTAG application, you can run your executable program. So in this universal shift register, our program file will be in the form of universal by the name of universal underscore sr.bit. So